With the release of Betaflight 4.5, we now have official support for the AT32 series of microcontrollers from Arteri. Now, if you don't know what the AT32 is, I have covered this in a previous video. However, today, what I'm going to do is give you a complete overview of what the AT32 is. We're going to take a look at a couple of AT32 flight controllers, and then I'm also going to walk you through the process of actually installing Betaflight 4.5 on them, because there are a few things that you do need to be aware of. Now, just before we get into it, I just want to say, if you find this video interesting, please don't forget to subscribe to the channel if you're new here. Also, don't forget to give the video a like. Any comments or questions, put them down below. And finally, if you'd like to support the channel, there are also links to my Patreon as well as Buy Me a Coffee in the description. Okay, so to start, we're going to talk about what the AT32 actually is and how it compares to the traditional SoCs from STMicroelectronics that we've been using over the last few years. Pretty much every flight controller we've used for the last 5 to 10 years has been based off STM32 microcontrollers. These are made by STMicroelectronics, and they're controllers that incorporate ARM CPUs on board. Now, ARM are the same company that design and make CPU cores that are used in so many devices, including smartphones, tablets, and everything else. They're not a company that actually makes chipsets themselves. They simply design the CPU cores, and they are then used by varying companies and manufacturers to integrate into their systems. In flight controllers, we've been using the STM32 series that allows us to be able to make these kinds of electronics really quite cheaply. They're quite low power flight controllers, but they have enough horsepower for us to be able to do things like run our PID loops, our software, and that's why it has really become the go-to processor type for FPV and drones. Now, there are a number of different types. You've got an STM32 F4.5 here. We've then, over the last few years, seen the introduction of the STM32 F series, all the way up to what I've got here on this test controller, which is an STM32 H series processor, which runs much faster, has newer cores than we've seen on the likes of the old F series. One of the massive benefits of the STM32 is the fact that it has been very cheap, very reliable, and very accessible. It's also extremely well documented, which meant integrating it into systems was fairly straightforward. Whilst 99% of flight controllers have been based off the STM32, there have been a few people who've done things differently, such as the old Eagle Tree Vector, which was based off PIC. However, today, pretty much everything that we have has been based off the ARM-based STM32. Now, whilst I did mention that one of the big benefits of the STM32 is that it is cheap and readily available, that did change in the human malware pandemic, and pricing actually went through the roof, and availability wasn't as good as it was before. Whilst that's largely resolved itself today, in that period we did see a whole host of clone flight controllers hit the market. These were basically drop-in replacements for the STM32. They were not, though, official ARM licensed products, and they were basically reversed engineered versions of the STM32 chipset. This is where Arteri or Arteri kick in. They are one of ARM's official licensees, and they are making chipsets officially based on ARM designs. They are designed to compete with the likes of the STM32 and offer pretty much the same or better functionality for lower cost and better performance. Now, over the last few months, we've started to see flight controllers ship from various manufacturers, including iFlight as well as NeutronRC, with the AT32 installed. And as I said at the start, we now have official support for this in Betaflight 4.5. Before Betaflight 4.5, you could actually use these flight controllers, but you had to use a special build of Betaflight that had support, whereas today they are baking that into the proper public versions that will be available to everyone. Now, both of these are based off the AT32 F4.5. If we take a look at the NeutronRC one, the first thing you'll notice is that it is a very similar looking chipset to the likes of the ARM STM32. You can see the Arteri logo there on the top, and it also holds the proper ARM logo down there as well. And as I've said, these are proper licensed ARM cores on these chips. They have pretty much all of the same functionality that we've seen on the STM32, but what the big benefit Arteri is bringing is the fact that they're making similar designs but with better performance than we've seen on some of the more basic ARM versions. For instance, if I just show you this chart on screen that I've put together, I've listed a couple of the STM32s as well as the new AT32 and showing you where it stands with regards to performance. We have the STM32 F411 and F405, which are both based on the STM32 M4 cores. We have the 411 running at 100 MHz and the 405 running at 168. They have 128 kilobits or 192 kilobits of ST RAM, and then you either have 5112 kilobits of ROM storage on the F411 or 1 megabyte on the F405. We then have the newer STM32 F722 and H473 chips, which are further up the list. These are based on the M7 cores and run a lot faster on either 216 megs on the F722 or up to 480 megs on the H743. They have more RAM and both have more storage as well. What's interesting when you look at the F722 though is that it sort of sits between the H743 and the 405 with regards to ROM storage, because whilst it does have 256 kilobits of RAM, it is limited to 512 kilobits of ROM storage, which may limit its use with the likes of ArduPilot and other flight stacks like Betaflight. What's really interesting about the AT32 is that it is still based on the older ARM M4 cores, but it runs much faster than the earlier F processors from STMicroelectronics, and it has more storage ROM as well. Looking at the chart, you can see it really does sit between the F405 and F722, but it is actually better than the F722 in many ways because it has a full 1 meg of storage. Processor wise, it is running on those M4 cores running at 288 megahertz. It has 384 kilobytes of RAM, 1 meg of storage, and if you look down the rest of the list, it is completely comparable with regards to spec to the STM32 models with regards to I/O, timers, and all of the other functionality. In many ways, this processor is actually a much better option than even the F722, because whilst it is running on the older M4 cores, it's not only faster, it has better storage, and it should allow you to get full functionality with the likes of ArduPilot and Betaflight because of its increased ROM. What's also extremely interesting when you look at the list is pricing. If you take a look at it compared to the likes of the STM32 F722 as well as the H series, it is dramatically cheaper, yet it is going to offer very similar levels of performance. Next, what we're going to do is take a closer look at these flight controllers in a bit more detail. We're then going to get them under the microscope as well, and then I will walk you through the setup process on Betaflight, but also explain the situation for all of the flight stacks, because there are some things you need to know, and there are some special drivers specifically needed for these new chips. Now, the first one we're looking at is the AT32 from NeutronRC. This flight controller costs just £20 in the UK, or in the US you can get it on AliExpress for about $25. It is based on the AT32 F7435, which runs at 288 megahertz and has that 1 megabyte of flash. It has the BMI 270 gyro, it has 5 UARTs as well as 1 I2C port. There is also some BECs on here as well, and an analog OSD chip. However, I can't really find any official specification for for the BECs. So what I would say is if you're going to use this with something like O3, I'd be going to direct battery voltage rather than the onboard BEC, because we simply don't know what it's capable of delivering. Now, just looking around this flight controller, there are a few other things. For instance, there's a wind-bond flash chip here. Whilst it's not listed in the specs that I've got, it appears to be 128 megabytes, and there is a baro sensor on this as well, which I'll spot under the microscope bit that you're going to see next that I hadn't seen the first time. Now, the board is 20 by 20 mounting pattern, as well as a 30.5 by 30.5 on the outside. Those 30.5 tabs are removable. You can snap them off, and you can see connectivity is handled by pads all the way around, as well as a couple of connections down here, one for the ESC, as well as another one over here for a few of the UARTs for a digital connection. Looking at the NeutronRC under the microscope, the first thing you can see is that chipset, the AT32 F435 RGT7. And again, as I mentioned earlier, you can see that official ARM logo down there at the bottom. Now, just moving around the board, just to look at the build quality, because this is a very, very cheap flight controller. All of the pins on the microcontroller look nicely soldered. I don't see any bridging, any problems there. Looking around some of the components up there on the top of the board, I'm not seeing any signs of tombstoning. All of the caps and all of the resistors are well placed on their pads. Again, looks absolutely fine. In fact, no complaints whatsoever. The board on this is sort of a dullish color. They don't have a lacquer on the top of it, so you would need to be a little bit more careful with regard to the handling. You could easily scrape one of these tracks, but overall, it certainly doesn't seem to have anything that raises any concerns. Flipping it over to the other side, we can see that wind-bond flash chip. We've then got a crystal oscillator there. We've got our OSD chip over there. We've got our power regulation stages, 2 power regulation stages, in fact, which is quite interesting. We've then got our connector there, which shows you the I/O. So you've got your R2, ground R1, T1, G, and 12, which I'm guessing is 12 volts from the output. So clearly there is a 12 volt BEC on here, and there is also a baro on here as well, which is hiding there, which wasn't listed in the spec. If we now just have a look around the pads at what's labelled, we've got ground, 5 volt, we've got our SDA there, STL32, our UART, our 12 volt. What's a bit frustrating on this flight controller is the spec published online isn't great. So for instance, things like I just mentioned, the baro sensor wasn't in the original spec that I was looking at. Neither was the fact that there's a 12 volt output as well. If we look up here, we've got our motor outputs manually, cam power, 5 volt as well as 12 volt. So clearly there is 2 BECs on board, but I need to go and have another look to see if I can find any info. But here and now, I've got no spec of exactly what it is, but there's definitely 2 BECs there. So with regards to power on digital, whereas I said earlier, you might not want to go directly on board. Actually, you may be okay, but with some of the more higher power VTXs, we're just going to have to see. Next, moving over to the iFlight. Now, this is their Blitz Mini AT435. This costs a little bit more, available for $29.99, and it's also available as part of a flight stack as well. Now, it is a bit of a smaller controller than the NeutronRC, but it is a bit more polished in the sense of it has more connectivity I/O. It is still based off that AT32 same chipset. It does have USB connectivity. We've got our ESC port, some ports over here for our receivers, our UARTs as well for connecting to your usual digital VTX. Spec-wise, it is based on the BMI 270 gyro. It has a barometer, which is the DPS 310. It has 6 UARTs, 16 megs of onboard black box storage. We have our I2C ports, smart audio ports, LED controller, beeper pads, and it weighs 5 grams. It does have a BEC on board, and it is 5 volts, 2.5 amps. So again, that's not going to be providing power for your digital VTX. You're going to be using that directly from battery with this one. Looking at the iFlight in a bit more detail, there we've got the AT32 chipset again, and if we now zoom in and have a bit of a close wander around the board, just to look at the quality, not expecting any issues from iFlight. Interesting, there's a pad there that's been masked off that isn't used on this flight controller. If you look there, we've got all of the pads soldered on that SoC. Apart from that one there, that does look like it's been left and masked off intentionally. I wonder if that's loose. Let me just get my tweezers there. I don't want to move it too much. Yeah, that has been left loose. Not an issue. It's not something you need to be aware of. You can see that they've masked off the solder pad that goes down to it. The chances are this board has been designed for the STM32 and they've done this as a drop-in replacement, and that's why that pad has been masked and left unsoldered. If we now just look around to see if we can see any others. Nope, no others. Just that one. Just that one up there. But again, nothing I'm particularly concerned about. But if you did see that, don't worry. They've clearly masked that off on purpose. Looking around the rest of the components on the board, everything looks nice and tidy. No sign of tombstoning. There's our baro sensor, which we knew about on this flight controller. Our LEDs, our button, all looking good. And then if we flip over to the other side, just look at the soldering. Again, you can see there, 2 masked pads on that AT chipset. Seems to be something that iFlight like to do. I've not seen that on another flight controller before. All of the components there look good though. Soldering of the wind bond chip looks okay. No complaints with the quality at all from iFlight. Pretty much exactly what we would expect. Looking at them both, whilst the iFlight is a bit more expensive, it's definitely a bit more of a complex flight controller. There's a bit more going on. I'd say the quality on the iFlight looks a little bit better, but that isn't to say that the NeutronRC is terrible. It's just that you're paying a bit more and you're getting a bit more for your money on the iFlight variant. Next, I'm going to walk you through the process of flashing these with Betaflight. Now, the process is going to be the same for the likes of iNav and ArdriPilot as well, and there is something that you need to do before you're able to flash. If you noticed in the past on other STM controllers, when you plugged it in for the first time, it would install some drivers. Most of the time, those drivers would be installed as part of Windows, and there wasn't really a need to go off and get separate drivers. There was the Impulse RC driver fix utility, which has been a fantastic tool to help people who have had problems on the STM32 chipsets. However, that will not work with this. If you tried to flash one of these AT32s without installing the correct drivers, Betaflight will detect the flight controller. However, when it goes to reboot and actually flash the firmware, nothing will happen. It will simply sit there waiting for the flight controller to reconnect. If you take a look at it in Device Manager, you will notice that there will be a yellow symbol next to the AT32 in DFU mode, and this is because the correct drivers are not installed. There is a specific driver needed for flashing these controllers in DFU mode. Now, I'm going to walk you through where you get that driver and how to install it, but I'm also going to put a link to that in the description, which I will host on my wiki as well, allowing people to be able to simply go there and download it. If you don't know, I do have my own FPV wiki now, where I will be hosting not only images of things like these flight controllers, but other stuff as well. There will be a link to that in the description, as well as these drivers that are available here for you today. Now, to install these drivers from the Arteri website, you simply go to the arterichip.com webpage. You then go to Support, and what you want to click on is Tool. You then want to look down here, and what you're looking for is the ISP programmer, which is this specific one here. You want to click and download that. Once downloaded and unzipped, you should have this list of folders, and what you're looking for is the Arteri_DFU_driver install. Then you want to open this program. It'll give you the option of installing the AT32 bootloader DFU, and you simply click install drivers. Once that's done, you should then be able to install Betaflight as normal. Simply allow it to either detect or select the flight controller from the list, click flash, and let it proceed as you would with any typical STM32 based one. Now, one last thing I just want to talk about is performance. Now, I'm still doing a lot of testing on this to try and understand the effect of those faster cores based on M4 compared to what we've got on, say, the 411 or the 405. As I mentioned, this chipset from Arteri should sit roughly around the same sort of performance level as the F7, but it does have benefits because it doesn't have that limited flash storage. It's not going to be able to quite keep up with the likes of the H7, but it is, in my my opinion, in many ways, a better option than the F7 series controllers. Now, there is limited information out there on ARM core testing with regards to the STM series. However, there is this one chart that does show us how the Arteri chipset performs compared to some of the others. And if you do some basic checks in Betaflight under tasks, you can see here that we have an STM32 F4.5 on a basic setup at about 18%, compared to on the AT32 to less than half at 8%. I'm going to be doing a lot more testing on this, and that'll probably end up in its own video in the future. There is a lot to look at on this because at this test they weren't actually on the same rates. There are differences between the performance of the flight controllers, the gyro rates and everything else, so it's not quite like for like, but there is a lot better overall performance on the AT32 in comparison. And for the price, it's an absolute no-brainer. In the end, what we have with the AT32 is a chipset that is cheaper, better performing, and in many ways going to give us a lot more options should the world melt down again in the future. I suspect you're going to see a lot more manufacturers releasing AT32 based chipsets here and now today, whilst there are some quirks, I believe, talking to the Betaflight dev team, especially around the core temperature measurement. Overall, the performance of it is very good. There are no major complaints with regards to stability, and it should be a very good option for us in the drone industry moving forward. It certainly won't end up replacing the STM32, but what it's going to do is give a lot more options, and that is always a good thing. Now, I really hope you have found this video interesting. If you have, please do let me know what you think in the comment section. If you have any questions, put them down there. I'll try and answer them as well. As I've said, there will be links to the wiki as well as the drivers below. And if you'd like to support the channel to allow us to keep making content like this in the future, please do consider checking out the links to my Patreon as well as buy me a coffee in the description. I want to say a massive thank you to my Patreons and everyone who has donated. And we also have channel membership available on the Mads Tech channel now as well. And if you'd like to support us to allow us to keep making content like this in the future, please do consider checking them out. There are links to them in the description as well. Anyway, that's it from me on this one. I hope you found it interesting. If you have, don't forget to give it a like. Stay safe, and I will speak to you soon.